Okay, don't forget we said any number exponent 0 is equal to 1. So this will be equal to 2 exponent x. So since the bases here are the same, it means that the exponents are also the same. So x is equal to 0. So we have one value of x. Let's try to find the other value of x. So also, when m is equal to the other one, that's m equal half. So when m equal half, what's the value of x? So let's see what the value of x is going to be. We are going to get 1 over 2 to be equal to 2 exponent x. Sorry. 1 over 2 to be equal to 2 exponent x. So we have 2 exponent negative 1 equal x. So x equal negative 1. So therefore, the values of x are x equal negative 1 or 0. So the values of x for this actual equation are negative 1 and 0. You can know whether the values of x you have are correct or are wrong. For you to know that, you just have to fix the values of x over here into the equation. If you fix it there and then you get 0, it means it's correct. If it is not correct, when you fix it there, you are not going to get 0. Okay? So this where, because of time, we are going to end on indices. We'll take a turn and look at logarithm from here. So whatever you have to write, you can quickly look on the board and then write it. You can pause the video over here. Yeah. Okay, so let's look at logarithm. What logarithm is about. So logarithm was actually invented by one man called John Napier. Okay. John Napier. This is the name of the man who invented logarithm. And he invented logarithm in the year 1614. But then he was actually born in the year 1550. And died in the year 1617. So what this means is that he died just 3 years after he discovered logarithm. That's so sad. He couldn't really live to enjoy what he did. He said the reason why he made logarithm was because he wanted to find a way that we could do calculations very fast, or in a more faster way. That's why he actually created logarithm. After this man, another man called Henry Briggs. After him, another man called Henry Briggs also added more to logarithm. This is the man who actually invented log in base 10. That's common logarithm. So the name of the man who invented log in base 10 common logarithm is Henry Briggs. And this man and another man called Clark were the ones who invented the logarithm table and all that. They did really well. They did really great work. So we are about to look at what John Napier did. So, as I said, indices was actually a prerequisite to understanding logarithm. So since we've understood indices, let's see something. If we have something like a exponent n to be equal to k, this is in the form of indices. By the definition of logarithm, this is equal to the log of k to the base a is equal to n. Okay? By definition of logarithm, a exponent n equal k is the same as log k to the base a equal n. Over here, a has to be greater than 1, and then k has to be greater than 0. Okay? These are two things we really have to take into consideration, that a has to be greater than 1, a is always greater than 1, and then k has to be greater than 0. I will create multiple videos about the reason why this will actually be the case. But then some people say this because if a is less than 1, or if k is less than 0, or a is less than 1, some people say maybe it may be indefinite or indeterminate, or it may be as a result of complex numbers and all that. But then we'll actually see the main reason in consequent videos that I'm going to make as to why this should be the case. But for today, we wouldn't talk about that. We'll just solve questions on logarithm. So, from definitions of logarithm, as I said, a exponent m equal k is the same as log k to the base a equal n. This is what we call the base of the logarithm. This is called the base of the logarithm. It is written as a small number here. So the log, we read it as log of this, log of k to the base a is equal to n. That's how we read this. So let's take a quick look and we prove the laws of logarithm. So let's look at laws of logarithm. The reason why we have to look at this is because if you're able to understand the laws of logarithm, that's the only way in which we'll be able to solve questions on it. So let's see. So let's look at the proofs of the laws of logarithm. So let's look at number 1. Supposing we have a exponent n equal k. We've learned from, right, we just learned that this is the same as log k to the base a equal n, right? Okay, so what if we have also a exponent n? So let's say a exponent n equal y. So this will also be read as the log of y to the base a is equal to n, right? The log, okay, this is going to be the log of y, no, yeah, that's it, log of y to the base a is equal to n, yeah. So what if we multiply this? So let's call this equation 1. Equation 1. Let's call this equation 2. Now let's multiply equation 1 by equation 2 and see what we are going to get. So a exponent n will be multiplied by a exponent n, and this will be equal to k times y, right? K times y is ky. Okay? That's good. So let me continue from here. So from indices, we know that when we multiply it this way, we have to maintain one of the base and then we add the exponent. So that's what we are going to do. A exponent n plus n, when we add the exponents, it will be equal to y, right? Now what we just learned will be equal to ky. Now what we just learned from here, we are going to apply the same understanding that we got from here, over here. Okay, so this is the same as log of ky to the base a is equal to n plus n. Okay, log of ky to the base a is equal to n plus n. Now let's see the meaning of m and n. We notice that over here m was what? Log k base a from here, right? So we'll fix it here. And then n was log y base a, so we'll also fix it here. So we are going to get the log of ky to the base a to be equal to m is log k base a. So log k base a. So log k base a plus log y to the base a. So this is one of the laws of logarithm. We call it the addition. Okay? So that whenever you add two logarithms, that's log k plus log y to the same base, we'll have to actually multiply them. Okay, that's what we do. So this for the law of addition. Let's take a typical question on this. We have something like log of 3 to the base 5. So let's say log of 3 to the base 2 plus log of 4 to the base 2. From here, this is the same as log of 2, then 4 times 3, which is